I do a lot of outreach activities with children, and one of the things I like to do is to have them make three-dimensional models, like that scale model of the sizes of the planets that I showed you in another video. This is an original thing that I made up myself. This is a model of the sun and solar activity. And so I thought I'd show this to you because I'm really proud of this, and I think it's really cool in showing how the different kinds of solar activity are related to each other. So it's yellow. The yellow represents the photosphere, the visible surface of the sun. It's not a real surface because you can't walk on it. Plus, you'd burn your feet. But be that as it may, the photosphere is what we see when we look out at the sun. Of course, you should never stare at the sun. But with a solar filter, we can safely block out 99.999% of the light from the photosphere, not only in visible light, but also in harmful ultraviolet and infrared, and we can actually look at the features on the photosphere. And the features on the photosphere generally come in two flavors. You have spots that are brighter, that look sort of whitish, and then you have ones that look darker, look black. And the whiter areas, which I've represented on here with some whiteout, so you can see those, these are what are called faculae. They're brighter because they're a little bit hotter than the rest of the photosphere. That makes them appear brighter. And the darker areas, those are the sunspots. And the reason why they're darker appearing is because they're a little cooler than the rest of the photosphere, and so they don't put out as much light. They are not actually black. If you could surgically remove a sunspot and hold it up next to the sun, you would see that it does put out light. It puts out less light. It looks darker. But in reality, it's not black. It's sort of a reddish color like the dying embers of a campfire. They put out less light than the roaring campfire because they're cooler. Now, you'll notice on here that I also have these sort of red pipe cleaners. This represents activity in the next layer out from the photosphere. That's the chromosphere. Chromo as in color. And the reason why I'm using the red pipe cleaners is because the chromosphere is sort of a reddish pink color. It's that color not because of its temperature, but because of the kind of light that it emits. Remember back when we were talking about spectra in the first unit. Remember that an emission spectrum has particular lines because of whatever gas is being excited. And the gas that makes up the majority of the sun is hydrogen. And one of the most important spectral lines of hydrogen is red. And that's called hydrogen alpha, as in the first letter of the Greek alphabet. And so this hot, thin gas in the chromosphere that's excited glows mostly in this reddish color. So if you have a telescope with a special filter that only sees hydrogen alpha light, that only sees this wavelength, you would actually just be seeing what's happening in the chromosphere. And what you would actually notice is that in the areas where there are sunspots, you can see these loops of gas that come up and go back down. That's why I have these loops here with the pipe cleaners. And those are called prominences. Now, the interesting thing about the prominences is that they tend to come out of sunspot groups. If you notice this sunspot group over here or the one over here, you notice that I have two sunspots, like two little eyes. That's because sunspots tend to come in groups, and those groups tend to be what we call bipolar. They tend to have two big spots, then maybe some little spots next to it. Think of it like an entrance and an exit wound from the sun. What happens is that the lines of the magnetic field of the sun pop out of the photosphere at one of those sunspots, loops around, and comes back in, sort of like a hernia. And what happens is that the gas will follow that loop of the magnetic field line. And that's why you actually have the loop here of the prominence. So this is where a magnetic field line of the sun is popping out of one sunspot, going back down in another, and then the gas is following that magnetic field line. So all of these types of activity on the sun are magnetic in their origin. The magnetic field of the sun is very strong and is very complicated. It's different from the magnetic field of the Earth because this is a giant hot ball of gas versus a relatively cool ball of rock and metal.